Hello, I'm Jack. Welcome to my channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In this video, we will use a WebGPU new version 0.1.14, which was just released a few days ago. The code runs on previous version can still run on this new version without any change. Previously, we discussed how to create a 3D surface chart with both the color map and wireframe, where we map a black square image onto the surface to generate the wireframe. The charts produced this way look nice, but have one issue. Except for the white color, you cannot get a wireframe with a true color because the color for the wireframe depends on the underlying color map. In this video, I will explain how to use a multiple pipeline approach to create 3D surface charts with wireframes that display the true color. We will do it using two pipelines. One pipeline is used to create a 3D surface with a color map using the triangle list primitive, and the other pipeline is used to create a wireframe for the surface using the line list primitive. Obviously, we cannot use a single pipeline to do this because a single pipeline allows only one type of primitive. Here we will use the Git tool to clone the source code used in the video 29. Here is the download link at GitHub repository. From this link, you can download all the source code used in the video 29. Now, let's start Visual Studio Code directly from Windows Start menu from here. This is a Visual Studio Code interface. Now, let's start a new terminal window. From this window, we cd into a code folder and then create a new folder called GPU53 and cd into it. We can then clone the source code used in the video 29 with the command git clone WebGPU29. After this command, leave a space and a period. This will place all our source code in the current folder. Run this command. We can check the source code direct. You can see the source code is indeed in the current folder. Now we can open this folder from Visual Studio Code. Open code GPU53. Here contains the source code used in the video 29. First, we need to create wireframe data. From the SRC folder, open surface data.ts file. Add a new function called simple surface mesh to this file. From here you can see the simple surface mesh. Compared to the simple surface data, here we add a new argument called dy. We set the default value to 0. This argument controls the location of the wireframe relative to our surface. If we set it to 0, which means the wireframe is located at the same place as the surface. This may result in discontinued line segment for the wireframe. Another thing is you can see here we draw the mesh data. You can see when I not equal nx minus 2 and j not equal to nz minus 2. We draw the two-line segment for each unit cell in most cases. This is one line segment, this is another line segment. However, at an edge, this means I equal to nx equal to 2, j equals to nz equal to minus 2. We draw 4-line segments to make a perfect wireframe. Because a simple 3D surface is usually open surface. So at the edge, we need to draw the 4-line segments. Inside, we just draw 2-line segments because we don't want to repeat to draw the same line multiple times. Okay, now we can save this file and close it. Next, we need to modify the shader code. Since our example is based on the project used in the video 29, the shader for the surface will remain unchanged. In order to add wireframe to the surface, we need to make some changes to the shader code used in creating wireframe previously. Now add a new WGSL file named math.wgsl to the SRC folder. Here we add a new file called math.wgsl. Now we need to enter some code into this file. This code is basically similar to that used in creating wireframe previously, except that the color of the wireframe can now be specified by the user. You can see we have a structure fragment uniform. This structure contains only one field, that is the color. This color can be specified by the user for the wireframe. Another change is that previously we pass a single here model view projection matrix. Now we need to pass separate model matrix and view projection matrix, which is necessary to match the uniform buffer used in creating the surface in this example. So that's two changes compared to the code we used previously. Now we can save this file and close it. Next, we need to make changes to the surface.ts file. From SRC folder, open the surface.ts file. Here, we don't need to make any changes to the code for creating our 3D surface. We only need to add the code for creating the wireframe. Now we need to replace the content of this file. Here we first introduce the math shader from math.wgsl file. The create surface with color map method here now accepts 3 additional arguments. You can see here we have math data and math 2 data and math color. These are new arguments associated with the wireframe. You can see we use 2 sets of math data and math data 2 to create 2 wireframes. One is located on the front face and the other one on the back face. The separation between these 2 wireframes is controlled by the parameter dy, as discussed before. Next, here you can see this defines our surface. So the buffer used to create the surface we didn't change, but we add the buffer for the mesh. You can see a mesh buffer and a mesh buffer 2 using the mesh data and the mesh data 2. And also this is used the uniform binding group layout used to create the surface without the need to change it. But we add a new uniform binding group layout 1 for the mask color. You can see here is only pass the color to the fragment shader. This is the original pipeline for creating the surface, so don't need to make any change. But we need to add a new pipeline called pipeline mesh, which will be used to create our wireframe. You can see here we use a line list primitive to create our wireframe. But here, before to create a surface, we use a triangle list primitive. So that's the difference. Right now, we have two different pipelines. One is for the surface, and another one is for the mass or wireframe. Here is the uniform data section. Here is the same as before, but you can see here we create a mass color uniform buffer. This is the new buffer. So we also write the data to this buffer using mass color. You can see here we create a uniform binding group. This is the same as before. We use it to create the surface. You can see we have vertex uniform buffer, fragment uniform buffer, and a light uniform buffer, all included in this uniform binding group. But here we create a new uniform binding group 1, which only contains mass color uniform buffer, so which will be used for the wireframe. Another thing is, before we just draw the surface from here, now we need to draw separately the wireframe. First wireframe, the front face, and second is another wireframe. We use mass buffer 2. Let's use mass buffer. So we first draw the surface, then we draw the two wireframes on the front face and back face. We just add the code for creating the wireframes. Code structure is very simple. So for the surface part, we don't need to make any change. We just add the code for creating the wireframes. Up to now, we have finished all the programming for this example, so we can save this file and close it. In next video, we will discuss how to use this framework to create simple 3D surface charts. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.